Deputy Vice Chancellor Administration, Deputy Vice Chancellor Academic, Registrar, University Librarian, Provost of the College of Medicine, Provost of the Postgraduate College, the Dean of the Faculty of Technology, Deans of other faculties and of students, Directors of institutes and centers, Heads of departments, distinguished ladies and gentlemen. The 611th University of Ibadan Inaugural Lecture will be delivered this evening by Professor Christopher Osita Anyaeche of the Department of Industrial and Production Engineering on behalf of the Faculty of Technology. Christopher Osita Anyaeche was born on 28 April 1957 in Jos, Plateau State, to Mr. Clement Udechukwu Anyaeche and Mrs. Victoria Chinyelu Anyaeche, both of blessed memory. Osita Anyaeche is a descendant of the Ike dynasty in the ancient Unobi. He started his academic training at St. Mary's Primary School, Damaturu, in today's Yobe State. His education was disrupted by the Civil War in Nigeria between 1966 and 1970. He, however, completed his primary and secondary education in Anambra State after the war. He then proceeded to the University of Ife, where he graduated in mechanical engineering in 1982. His National Youth Service Corps program brought him to Ibadan, where to date he has spent most of his adult life. After a stint at Leyland Nigeria Limited, he proceeded to the University of Ibadan, where he completed his MSc program in 1988. He then went back to the industry and worked as a service engineer, workshop manager at CFAO Motors at Ijora, Ibadan, Port Harcourt, and Ikeja. He left CFAO Motors for Deal Markets as auto workshop manager. Thereafter completed his PhD degree in industrial engineering in 2006 and joined the services of the University of Ibadan in the Department of Industrial and Production Engineering in the year 2007. Professor Anyaeche's academic journey in teaching, research and community service is marked by a commitment to knowledge. His early career saw him engaging in research that addressed critical industrial challenges, leading to innovative solutions that have had a lasting impact. His tenure at the University of Ibadan has also been characterized by dedication to teaching, research and community service. Through his mentorship, many students have gone on to become successful professionals in engineering, academia, and related disciplines. He served in many capacities, including the head of the Department of Industrial and Production Engineering between 2015 to 2017. He also served in the Department of Biomedical Engineering as well as the Medical Laboratory Science at the College of Medicine of this university. Professor Anyaeche has authored and co-authored books, numerous research papers, published in reputable international and national journals. He has over 80 publications in referred journals, conference proceedings, books, chapters in books, and a patent to his credit, demonstrating the significance and the impact on the engineering community. His research interests include industrial optimization, productivity systems, sustainable engineering practices, biomechanics, artificial organs, and product development. He has led research for the development of systems and products addressing specific challenges and problems. His work has contributed to solving complex industrial problems, leading to safety, improved productivity, and efficiency in various sectors. Professor Anyaeche has taught many generations of students, supervised many bachelor's in engineering degree students in different universities, over 80 students at the master's level, and had successfully supervised 4 PhDs. He is currently teaching and supervising at the 3 levels and a professional master's program. He was a visiting scholar at the Northwestern University in Chicago in the United States in 2014, and currently an external examiner to different universities at various levels in both industrial and production engineering as well as biomedical engineering within and outside the country. He has served as both internal and external assessors to professorial promotions in different universities. He is an SAP certified consultant and trainer, and member of the Nigerian Society of Engineers, Nigerian Institute for Industrial Engineers, Nigerian Institute of Management, and a registered engineer by CORE, among other professional bodies. Engineer Professor Christopher Osita Anyaeche is the current national chairman of the Nigerian Institution of Industrial Engineers, a division of the Nigerian Society of Engineers. Under his leadership, clap very well for him. Under his leadership, the newsletter and the industrial digest have been revived, which were last published in the 1990s. He is the current editor-in-chief of both publications. He serves on the editorial boards of many journals and publication outlets and has participated in organizing and attending many symposia, workshops, conferences, both nationally and internationally. He is a member of the Correctional Center Visitation Committee, and with other members, they believe that if the correctional centers work the talk, inmates should be rehabilitated by providing viable vocations and skill acquisition to complement the spiritual administrations at the center. Sir Engineer Professor Christopher Osita Anyaeche is a Knight of the Order of St. Christopher, KSC, and a Diocesan Merit Awardee, both confirmed on him by the Most Reverend Dr. Williams O. Aladekugbe, Archbishop Ecclesiastical Province of Ibadan, and the Bishop Ibadan North Diocese Church of Nigeria Anglican Communion. Professor Christopher Osita Anyaeche is happily married to Mrs. Amaka Anyaeche, and the marriage is blessed with children, Adaobi, Obinna, Kenechukwu, and Uchechukwu, all to the glory of God. Distinguished ladies and gentlemen, and I invite Sir Professor Christopher Osita Anyaeche to deliver his lecture, which is titled From Complexity to Clarity, Operations Management and the Pursuits of Work System Excellence. Professor Anyaeche.
Protocol. The Vice Chancellor, Deputy Vice Chancellor, Deputy Vice Chancellor, Academic Deputy Vice Chancellor, Research, Innovation and Strategic Partnership, Registrar Boxer, University Librarian, Provost of the College of Medicine and of the Postgraduate College, Dean of Faculty of Technology, Deans of other faculties and of students, Directors of institutes, ladies and gentlemen, a humbling experience. It's both an honor and a humbling experience to stand before you today to deliver the 611th inaugural lecture of the University of Ibadan, the 33rd in the Faculty of Technology and the 4th from the Department of Industrial and Production Engineering, titled From Complexity to Reality, Operations Management and the Pursuit of Work Systems Excellence. Followed next is the list of previous lecturers in the faculty. The university's long-standing tradition. These milestones reflect the university's long-standing tradition of scholarship, intellectual depth, and academic excellence. An inaugural lecture occupies a special place in academic life. It is not merely a formal presentation of scholarly ideas. Rather, it is a moment of reflection, a moment to pause and consider the journey that has brought one to this stage. The mentors who have shaped that journey, the students who have inspired it, and the field of knowledge that has defined one's professional life. Inaugural lecture from the IT department. Within the Department of Industrial and Production Engineering, previous inaugural lectures have consistently emphasized productivity, innovation, and optimization, while maintaining a strong human perspective. From Professor Lulu's work in the nexus between industrial engineering and development through Professor Charles Owava's the synergy between humans and machines to Professor Oladuku's resilience and optimization, a clear pattern emerges. That is the integration of technical systems with human values. This lecture builds on that tradition by examining work systems through the lens of operations management with a focus on transforming complexity into clarity, the human elements. Inaugural lecture is also an opportunity to share ideas with the wider academic community. Universities exist not only to preserve knowledge, but also to expand it, question it, and apply it to real problems in society. In that spirit, this lecture explores a simple but powerful idea that complex systems that surround us, systems in industry, healthcare, education, and government, can be understood, improved upon, and managed through the discipline of operations management. Today, we shall explore the work process from the operations management perspective. Operations management is the science and art of transforming resources into value. It examines how organizations coordinate people, machines, materials, information, and energy to produce goods and services that benefit society. However, the environment in which organizations operate today is increasingly complex. Technology evolves rapidly, markets expand globally, customers expect speed, quality, and customization. Environmental considerations demand sustainability. In such an environment, the ability to move from complexity to clarity becomes not only essential, not only useful, but essential. The rationale for the topic. The modern world is characterized by increasing complexity. Beyond this, human beings interact with machines, machines interact with other machines. Many modern technologies replicate human capabilities, further increasing system complexity. As organizations evolve, they must manage multiple processes, diverse technologies, numerous stakeholders, increasing expectations. If these are not properly managed, this complexity leads to inefficiency, confusion, and poor performance. The central premise. Complexity can be transformed into clarity through deliberate system design and effective management. Operations management provides the framework to achieve this transformation through 4 key principles: simplification, standardization, optimization, and sustainability. Together, these principles enable organizations to achieve clarity, efficiency, resilience, and excellence in their operations. My journey in engineering. Like many journeys in science and engineering, mine began with a question. During my early schooling, our teacher, Mrs. Sistema, introduced our class to algebra through a simple equation. 6 plus x equals 10. And I say that up to today, algebra remains my best subject because of this woman. At first, the introduction of letters in algebra seems puzzling. Numbers we understood, but why introduce symbols? Why ask us to find x? Is x missing? X is in our ABC. Why is it going into arithmetic? The teacher explained it with a simple example. Imagine a basket that can hold 10 oranges. If 6 oranges are already in the basket, how many more are needed to fill it? The answer, of course, is 4. In our algebraic terms, that 4 represents like X. Inspiring teachers have not shown my curiosity. Mr. What's up? That moment was small, almost ordinary, years is revealed an important truth. What appears complex often becomes clear when viewed. Later on in secondary school, inspiring teachers, especially training in SEPC Idigo, nurtured by curiosity about mathematics, physics, and chemistry. Inspiring teachers encourage careful thinking, patient analysis, and a willingness to ask questions. Those were the building blocks that earned us admission into the universities. They taught us almost with nothing, just after the war. I proceeded then from the then University of Ife, where I earned a BSc in mechanical engineering. Another turning point. Another turning point occurred during my national youth service at Lela Nigeria Limited. I'm happy that some of my colleagues are here today. On the production floor, I noticed engineers who were not directly operating machines, but we are observing the entire production system. They carried computers and were measuring instruments. They analyzed workflows, they studied efficiency. They were industrial engineers. Their work fascinated me because it addressed not just the machines, the systems. That encounter shaped the direction of my academic life and led me into the discipline of industrial and production engineering. Dimensions. In the field of operations management, complexity and clarity represent two important dimensions of organizational performance. One way of appreciating the complexity of any venture is the number of items, dimensions, to monitor at a time. In our elementary physics, we were taught that time, mass, and length were the basic dimensions. At a higher level, though, we consider building information modeling, BIM. Consider a coin. I assumed it had 2 sides until a friend told me that there are actually 3 sides to a coin and not 2 as many believe. You'll find that the circumference of a coin is a side. Another friend then added that on complexity, that indeed coins may have up to 10 sides, surfaces, or multi-sided edges. He then explained that further that such simplistic assumptions, example, a coin having 2 parts, 2 sides, at the bane of our misses, inefficiencies, ineffectiveness, and poor performance in diverse activities. What we're saying is that if you don't sufficiently capture the factors and the variables and the parameters in the system, you can hardly effectively handle that system. Complexity and clarity in work systems. I'm sure we've seen the display there, the Nigerian coin. I'm sure the younger ones may not know that Nigeria at the time had coin. If you look at that, you see it has varying edges. Of course, are there no size? With this, can you say that a coin has 2 sides? And now it depends on the level of complexity you want to go. If you just want to take 2 of them and say 2, you can go 3. In terms of technical anatomy, most real-world coins stop around 12. Once you get to that, it becomes something else, difficult to manage. Complexity and clarity in work systems. Of course, complexity, and everyone prover said that confusion is the enemy of understanding. How do you find complexity? Difficulty in designing, managing, and controlling work systems. It increases cost, errors, and stress, and of course, resulting in waste. Reality can be achieved through simplification, standardization, operation, and sustainability. It reduces errors, improves productivity, enhances morale, and trade. Modern organizations. Modern organizations operate in environments that are more interconnected and dynamic than ever before. First, technological advancement continues to accelerate. Second, globalization has expanded supply chain across continents. For instance, a product designed in one country may be manufactured in another and yet sold across multiple markets. Third, customers expect more than ever before. Fourth, organizations must now address sustainability. These forces combine to produce systems that involve numerous interacting elements. The nature of complexity. A typical organization system includes people performing tasks, machines performing mechanical operations, materials moving through production process, information systems coordinating decisions, and organizational rules guiding behavior. When these elements interact without clear structure, complexity can easily become confusion. Yes, complexity in itself is not necessarily undesirable. In fact, many sophisticated systems, from aircraft to hospital to global supply chain, must necessarily be complex in order to function effectively. The challenge, therefore, lies not in eliminating complexity, but in managing it wisely. Building information modeling. Now we have a sort of taking the different dimensions when you're trying to study building information modeling. One, at the very bottom there, you have triggers. The triggers don't have any dimension. The first dimension could just be a dot. In geometry, you can draw the x, y, or z. Two dimensions, x, y, that is length. Further on, you have the length, time, cost, until eventually increasing until you get to industrialization, which is about the tenth. If you take it in reverse order, then you keep reducing until eventually you get to the triggers. And that is simplification in quote. The complex clarity matrix. You can see different combinations of complexity and clarity, but you go for high complexity, low complexity and high clarity. That will give you very efficient systems. Other ones will be sub-optimal in performance. Resolving complexity, a systematic approach. How do you resolve complexity? First of all, you must acknowledge that there is complexity. Second, you define the purpose. Third, you deconstruct the complexity. Fourth, you eliminate non-essentials. Fifth, you get the structure and pattern, translate into clear languages, validate through feedback, and of course, sustain reality. Frameworks. What frameworks you need to study them? We have here 2 7S frameworks. The first one is the one that is done in the social systems, where you look at strategy, structure, system, staff, skills, style, and shared values. Clarity in this when all the 7 move in the same direction. What about in shop floor, manufacturing? We consider lean management or lean production. There you sort, you set, you shine, you standardize, you sustain, you bring in safety and of course spirit, which will help to cultivate group engagement. Theory of constraints. Every system has at least one constraint limiting its overall performance. Improving anything else besides the constraint has little or no effect on its total output. And what do? Identify the constraint, exploit it, subordinate it, elevate it. The moment you do that, another constraint will emerge to repeat the process. The economic question. Of course, we know that resources are scarce, and the needs are once almost unlimited. So, in classical economics, you consider 3 of them: what to produce, how to produce, are you producing for who? However, in modern economics theory, you look at how efficient is the system, is the economy going or stagnant, is the distribution fair? What is the concern of an engineer in this? The engineer wants to see productivity, quality, cost efficiency, resource utilization, and sustainable production. What are the metrics? Again, before we look at metrics, look what are the different types of work. Work essentially can be categorized into 2. Any activities you're doing can be categorized into 2. One, especially in production, value adding. That is the one that the customer is ready, willing to pay for. Necessary, but not value adding. Transportation, could be inspection, could be quality control. These do not directly add value, but they are necessary. Of course, the waste, reward, waiting time, unnecessary movements. What are the metrics? Productivity, efficiency, cost, quality, time, reliability, inventory, and safety. Now, every system, what you try to talk for is increase in productivity. And there are about 5 scenarios that will give you that. Of course, productivity is output over input. My teachers are here. Now, look at that ratio. If both of them are increasing, but output is increasing at a faster rate, you get a positive result. If output is increasing, but input is decreasing, you get positive results. If output is decreasing, but input is decreasing at a faster rate, you still get positive results. And that last one could be looked at as input compression. Again, what are the other scenarios? Now here we have input-oriented studies where you might be satisfied with the output, the first one, but you now do the gradual reducing of the input. That again is input compression. On the other hand, there are situations where you are satisfied with the input you have, but you want more output from that. That, of course, will give you an increase. So those are the 5 scenarios. And what are the framework and philosophies for systems excellence? Lean thinking, quality management, theory of constraints in industry, called human-centered design and sustainability. Of course, we want the whole of this to go together, and that is why we have integrated knowledge flow. When we're able to combine this from where you identified it to get the reality. My contributions. Essentially, my contributions can be divided into 3. 1, industrial safety. Then my experience as a young manager in the industry. Some of my friends are here. Then research outcome. Now, next is vehicle inspection kit. Now, the pit you have there, if you look at the one on the left, the ladder, the axis is a ladder, vertical. On the right, you have steps. When I got in there, what I made on ground was what you have on the right, on the left side. That is not safe. And we'll demonstrate it. I insisted, what my teachers taught me, that what you should use is the step one. Because it's safer, you can easily escape from that in case there's an emergency. Not long after that, there was an emergency. The pits or bays, about 5, 6 of them, they are interconnected due to drainage. So one of the operators walked on one, dropped the fuel tank, and carelessly or how petrol leaked into the system and now spread across. Later on, another operator went at another end and was trying to weld. The moment the light came on, it was engulfed with fire under the vehicle. But as God will do it, we already adopted the step, and that helped us to save life and the emergency. To God be the glory. Oftentimes, I look around this campus as I see that thing that we have on the left. You can mention where they exist here today. I saw one again, a couple. Mr. Vice. My experience as a young manager. When I got to this company, I was assigned to audit, review, and write a proposal to improve the performance, especially the bottom line. In the industry, what they want is bottom line. Every other thing is grammar. And of course, with the training I had, I went with all those metrics and so on. And to God be the glory, they said I got them a very brilliant proposal. I didn't know it was a trap. The next thing is that I was now moved to take over from who was operating that to go and implement that my brilliant proposal. To the glory of God, we did our best and we got the best out of it. And production workshop. Yeah, what you have on the left is what we met on ground, but we applied our 7S, which we have enumerated, and produced what we have on the right. And of course, during our presentation, that does give credit to the glory of God. The research output, system design. This symbolizes in a way capital simplification. Here we did a couple of things. We developed economic workstation, scorecard, air quality, bomb, world measuring system, exhibit content, contactless exhibit dictator, low cost drip irrigation system, amongst other including our circuit economic scorecard. Mr. Vice Chancellor, sir. A comprehensive industrial engineering needs to fit the job to the worker rather than forcing the worker to fit into the job. Work environment should therefore be designed to match human capabilities, comfort and safety. You tell me whether that was operates. We found out that and we did a pilot study and the result was not encouraging. We wanted to evaluate that was not. So we went ahead now with one of my former students, and developed a economic work scorecard for work sessions. That's what we have next. So we evaluated one, lecturer's office, the lecturer also evaluated classroom, of course, workshops and labs. We can probably report that the lecturer's office registered about 75%, classroom about 65%. Mr. Vice Chancellor, we are now bold enough to report what we saw in the workshop and the labs and in some offices. That led us to go further and try to assess the air quality in some of these places. There are some offices you enter into, you want to have people arriving there, and we report them around. So in some labs, where they have some. So we did a study and found out that in some of these places, all the contaminants, concentrations were exceeded what the WHO recommended. Surprisingly, the workers were aware. But nonchalant attitude, nobody was enforcing it. And that is how people die gradually. Next, that's one of my students who was collecting data. You can see in that picture somebody seated on the right is smiling at a workshop. Probably he's economically comfortable. And I asked you, I hope you are economically comfortable where you sit. Yeah, give me the answer later. Yes, born wound and monitoring system. Yes, this is a collaboration we did with University College Hospital, UI, Northwestern University in Chicago, in the US. We got this challenge from Dr. Mike Mrs. But wounds are treated and they use bandage, which they call a Gamgee. Gamgee is very expensive. You don't want to change it too early because there's a lot of discomfort to the patient. And you don't want to change it too late because it will result in what we call Sky 2, which has a very high risk factor. So, in industrial engineering terms, what is the optimum time to do that? So we designed that wearable device you have there that will give you either red, green, or yellow. If it's red, then that's a Sky 2 and you don't want it. If it's not there, if it's yellow, maybe it's still okay to be watching it. But the other one. Yes, contactless device for moisture detection. Now, the first one we showed has direct contact with the Gamgee. But you can also use contactless principles, and that's what we did in the second one, where we developed a device that with a sensor at a reasonable distance, it can pick how close the exudate is to the surface. Of course, next you see the picnic refrigerators. These are projects for my students. What we have on top is an AC operated picnic device. It's still operating over 10 years, we got it on. The one you have at the bottom is AC, DC, and it can even be solar. So that's also. These are waiting for mass production. Then we went to agriculture. What can we contribute as operations managers? Yes, one of the things we identified is that people don't be able to produce the whole year because of this water problem. Not that the crop cannot grow. So what did we do? We now have to develop a low-cost drip irrigation system. Low cost, which you can use as a backyard. What you have there is Mr. Babatunde, one of my former university students. He was calibrating those pipes, and there are a set of ranges of crops that you end up at those nozzles. So each of them will be calibrated to the water requirement of that particular crop. And you have a container there where you fill in the water. Of course, this design was validated a cost-effective irrigation system incorporating frugal use of water in agriculture. Assistive devices. Here we designed customize the chairs for the workers, for patients. In particular, one of the ones is the custom wheelchair for the paraplegic patients. Yeah, you see my student there below, taking anthropometric dimensions of a patient. So with that, we design and develop what you have on the left. That is customized for that patient, and it takes care of his comfort, his mobility, his needs. It is specific for that customer. Again, mass production awaited. Low cost working stick. You can see low cost because within our economy, some of this exists issue, but it's very expensive. So try as much as possible to use industrial engineering principles to drive costs down, yet keeping the efficiency. Yes, from that table you see there, out of a population of about 8 billion, 2.2 billion are visually challenged. About 0.5% are blind. In Nigeria, 4.25 million are visually challenged. About 1% are blind. That will be sending some message. So what did we do? We developed a low-cost smart walking stick, which a visually challenged person can use. Within a range of about 5 cm, you should detect an object with a sensor there, and of course a larger coverage of about 120 degrees. Once that is done, you can see light to notify whoever is holding that stick that this is something to avoid. In that case, you will now have to navigate yourself out of that. Again, next we see where we say that there are needs for learning devices that will assist in operating a theater. Here you see a couple of students trying to see what their surgeon is doing. It's difficult for them to assist, and that's how close, if there's a minimum distance, they will have to stay away from the surgery point. So, but how will they learn? You can see they're just hanging around there while the actual is happening, you know. So what do we do with the developing device? That the camera should be mounted on top, you can see that, and whatever is seen is transmitted to displays. Now, the displays could now be for the students to see exactly what's happening. The second display could be in the chief consultant or whoever, because it can also be remotely transmitted there, whether you want to use Bluetooth or some other technologies or cloud. And in fact, you can use this system even all over across the world, because anywhere you are, once you are to cloud, you'll be able to access this. Of course, another advantage there is that it can be recorded for review. The next, the team of those who did that, the next there is Dr. Michael Mrs. Next, we apply the system dynamics to develop broadband. That is for product development. Then patent information. Here again, we developed an auxiliary temperature monitoring device. What is the work of this? We are told that any individual's temperature will give you a measure of how healthy or not he is. So why don't you monitor that? And even in some patients, you need to monitor it on a continuous basis, maybe 24/7 for weeks. So we developed this device, which you can use to record, how you try to record the temperature of that particular patient, so that yes, you can know how he's faring. You see the display. Again, this can be displayed remotely, where you can sit in the comfort of your room, whether you're on duty or not. You will monitor the temperature of your patient that is maybe some miles and distance away. This particular one has been patented in 2024, again, looking for mass production and commercialization. Operations planning here. You know, we talked about standardization. What do we do with standardization? We studied, because we took productivity, for instance, we did know that the productivity, for instance, appears to have captured or summarized most of the things that once you get them right, once you get your productivity right, you must have somehow, you know, been able to address that. We studied a couple of productivity models, Stanley, Craig, Hayes, APC, NPC, up to that 10, you know, about 2002. Now, if you look at what you have in the middle, that green, in productivity, you are looking at productivity, price discovery, and profitability. But you see gaps, so something is missing. Again, for the focus of analysis, some will focus on input, while we will not focus on output. So what do we do? There are two challenges here. One, incomplete information. In fact, we found out that if you use the one that is input-oriented and apply it to the one built as output-oriented, you get different results. That means that could lead to wrong decisions, and in fact, it has in the past. So the one you are doing your analysis and you are not getting it right. Then the second challenge is that many organizations, if it is a normal practice somewhere, I don't know, that you use previous results, guys, to access this year. No, that is just a trend. Before you can get what this year is supposed to do, you establish the potential for this year. Machines are depreciated, human beings depreciate. So why do you use my last year's performance and capacity to assess me this year? No. So what do? We say that there should be a reorientation. Now, we develop the input-output productivity model, where you now focus on covering all those things you're seeing, there are those gaps, so that you are evaluating both input and output at the same time. And of course, you have your productivity, price recovery, and profitability. That will give you a consistent result. Then for system potential, what did we do? We said establish the potential for that year. How do you establish it? You use principles, just like principles, all of the optimization principles, the LP and the rest of them. Establish the capacity, establish the potential, then use that potential to assess it. What that means is that subsequent years, you continue doing that to get exactly what you want. Next, you see the ILP model. On the right there is the flowchart for it. This approach strengthens performance evaluation by integrating operational inputs, output, and financial outcomes into a unified analytical framework. Of course, the system potential here specifically applied LP in our program to establish the potential of that system. And of course, on the right, we have the flow chart. The model supports strategic planning, capacity prioritization, and improves standardization of productivity evaluation by linking productivity assessment to system capacity. Next, multiple perspective productivity evaluation. We found out that so many people are interested in productivity evaluation. Companies are to be interested, workers are, engineers are, social scientists, economists, mathematicians, almost everybody. And each will address it from each perspective and think that it's right. No. So we developed a framework for a multi-dimensional framework that provides a more comprehensive understanding of productivity performance across board. That was published in 2000. Now, next is the summary of the productivity table. So if you look, first of all, we presented 1 to 10, and you can see so many gaps. But 11 downwards, there are many more. But we just listen to that. You see, all those gaps are filled in whether productivity, price recovery, profitability, input, outputs. And those are some of our contributions. Productivity planning, predictive and planning models. Now, we're talking about evaluating what is happening. What about the future? Performance management. You deal with the past, the present, and the future. So as a performance manager, what do we do? Again, many productivity, existing productivity models, we are looking at efficiency. But we said no. You can also look at productivity growth as a strategy for the organization. I developed productivity growth strategy model, and of course, with that, an organization will understand can go through systemization, bureaucratic, or entrepreneurial. Then, of course, what do you want to do? There are strategic actions you can take to stabilize the right size and redevelop. You don't say downsize, you say right size. Because it's possible either you increase it up or you scale it down. And of course, activity-based modeling for estimating manpower cost of university education. I'm happy that this will be interested in this. What did we find out? Borrowed courses cost more. And that means something has to be looked into why borrowed courses cost more than the costs that are offered to the partner. Productive planning again. Now we looked at how else can you look at this productive model. So we developed an ANN, actual neural network. So we do that. You can see the ANN model for planning production. You can see the display. Of course, again, we went further. ANN and linear regression. Because some people are saying that linear regression is okay. Yes, it's okay. But when we now compare the two, we actually is ready to establish that ANN does better. So, results and findings. Simulated data set. Now, you know the inputs you are planning to use, put into your system. You can run it and know the possible output. Beyond that, you now decompose your productivity, price recovery, and profitability. When you simulate in such a system, you can, even just using your laptop, project and do an analysis so that you know what best can I put if I'm requesting a certain level of performance. So the findings demonstrate the value of data-driven models for operational planning, monitoring, and performance forecasting. Next, we look at production process guide. Here, essentially what we did was to study the production process of composite materials. And we found out that there are challenges when you're trying to develop a composite material, you ask somewhere, you do somewhere. So what do? We try and develop a model that, yes, will give you clearer approach for doing that so that you reduce the errors that I have if you're trying to maybe do trial and error and all these so many wrongs. What are the takeaways from these models? One, productivity models optimize processes. They provide structured ways to analyze, forecast, and improve. What are the benefits? Clear assumptions, enabling clear hypothesis, support forecasting, enabling simulation, predict productivity, and reduce operational costs. What are the takeaways? For the industrial application, you have drives economic growth and improvement. It enhances real-time performance and monitoring, and of course, you can use that to predict. Then again, it facilitates improvement. For the individual, what you have to take away from productivity models, it improves time management, gives you clearer focus and goal achieving, and also how to prioritize what you're doing instead of procrastinating. For the employee, it gives you an opportunity to study your clear metrics that you now have to use to, you can even assess yourself. And of course, what the overall contribution on the economy, better standard of living for everybody, supply chain and optimization. Now, every activity you are getting involved to will have somehow cost, time, quality, risk. The moment you try to improve one, you are likely to lose in the other one. So the question is, how do they interplay so that you now have what we call an optimal level? And of course, that means you have to trade off something to get something. So one of my PhD students then, Mr. Anyaeche, today is Dr. Anyaeche, we developed a multi-objective optimization model, which that was in 2015, and this was applied to different scenarios. One of them, MRI installation and project optimization. I want to report that this particular project did well in the beginning academia. Then when we took it to the industry, it was not user-friendly. So we got back, what do we do? We now developed a graphical user interface. And what you have next is the flowchart for that, and on the right is the user interface. This development work is to optimize trade-offs across cost, time, quality, and risk. Mr. Vice Chancellor, sir. May I report that this project was taken to a conference in 2015, and that's Dr. Anyaeche, then Mr. Anyaeche, receiving award for Excellent Paper Award in 2015 in Dubai. Further then, we applied it in direct transportation, reliability, and digital operations. Most applications using Six Sigma, we will be looking at defect reduction. I will say no. Why can't we also look at zero injury situation? Can you actually develop it in the system, track that error, what is causing that injury, and develop a zero working situation? And of course, you know, in some applications, it's zero tolerance for failure. So how do you do that? You use Six Sigma to do that. And that extends Six Sigma beyond defect detection to injury prevention, statistical process capability, and analysis for manufacturing safety. Of course, safety engineers will tell you is safety first, safety always. Of course, again, we apply this Six Sigma and some other applications, patient flow, asset management for biomedical engineering equipment. Then, of course, in machine learning. But of great interest to us is the optimal maintenance policy for fleet operators. Now, if you have a system where you want to look at that system, how is it, and how is it likely to be the following year? If you subject that to probability studies using Markov process, you can say, okay, this is how it is this year, this is how it's likely to be, given the history of that system you have. So, we use what we call transition matrix. If, for instance, you examine your system and see that 1, it can be as good as new, 2, in a B minor service, 3, it might be major service, then 4, it might be inoperable, where it will not serve your purpose. Now, how do you match that with the level of production you want? If what you're anticipating to sell or something, market the following year is not much, maybe you'll be satisfied with minor service so that you can cope until you get out of that bad economy. But if you know that something big is coming, of course you have to do major overhaul or replacement. Is the transition matrix that will help you to do that. And with that, and we did that, and we got an analytic procedure for value added to different production levels with different policy options. And of course, some of the policy options we either to replace, we either to repair, and so on and so forth. The approach is stochastic, thus provides a framework for informed decision making on productivity growth under uncertainty conditions. Optimization of productive planning with machine learning. Here we applied machine learning and to also do some planning about production. This particular one integrated machine learning forecast and map in Six Sigma optimization to improve productivity, production planning accuracy and reduce waste. Complexity and clarity operations. Here we look at the different options you have there. You define it, you design the design process, decision making. Complexity will require analysis of many factors, cost, quality, and so on. While clarity, decisions guided by clear rules, KPIs, and priorities. Again, if you look at response to change, complexity, changes are harder to implement and predict. If it's clear, changes are easier to understand and apply. Managing focus, controlling variability and interconnection. That is what the money will be engrossed in a complex system. But if it's clear, simplifying processes and improving understanding. Conclusion, the clarity chain. Of course, first of all, understand the complexity, simplify, standardize until you get to excellence. Integrated flow. Yeah, we are saying that this integrated flow, don't take them as standalone. Take them as a flow process. They begin with system simplification, advanced through standardized planning and control models, extend to optimization of resources, project and investment, and culminate in sustainability through maintenance, quality, and human-centered design. The clarity chain. Again, that's what we're saying. Have it as a chain. Have it as a chain. Then conclusion, I will say complexity allows operations to handle variety in scale, but increases difficulty in control. Recommendations. So we are concerned about graduate employability, and we recommend that establish industry and teaching partnership closely will help us to close the gap between academic for output and market expectations. Of course, we also recommend that business models and units should be established to convert all these designs, projects into value products. We have values are created. Then the government workplace for stations, we talked about that. It's a license to us. It's our prayer that under your tenure, you give the Department of Industrial and Production Engineering its own building. Thank you, sir. Acknowledgement. With profound gratitude, I acknowledge the grace of God, divine God in me, and I thank God for making it possible for me to be here today. Through many dangers, storms, and snares I have come, is grace that has brought me so far, and grace will lead me home. That's John Upton, meeting 1772. Next, you see my parents. That's my father and mother of blessed memory for believing in me. On the right was my father during my graduation at the then University of Ife. Next, I thank the Vice Chancellor and University Management for making our work environment operationally less complex. My teachers in the primary and secondary school, that Mrs. Ife who was asking me to find X, when X is not missing. Thank you, Madam, for leading me to algebra. As I said, algebra has remained my best subject. Of course, MC who taught us with almost nothing, because our workshop, our labs are completely devastated by the war. Next is Sir Prof. Engineer Moraki, he is standing here for my teachers at the University of Ife. For my first degree, then that's the new student there. Then of course next my teachers, Mojola, Jakai, and others. Then my class of 1982. My teachers at Ibadan, Osifu, Olorinuwo, Charles Owaba, Osoluleye, and Akambi. Next is my graduation MSc ceremony. Then my teachers at PhD level, Professor A.E. Oluleye. We call him Professor of Professors. He's the only person that is not wearing an exam there. The rest of us were at our graduation. 2 of us were supervised by Professor Oluleye. The other 3 were supervised by Professor Charles Owaba. And to God be the glory, everybody you see standing there today is a professor. Let me then add that just today I got to know that if your student is a professor, it means you are a professor, And they just been confirmed that I am now a professor, Yes, I pass it through this. I appreciate you all. My colleagues and friends, especially Professor Victor Olaboku, he made sure that I made this presentation. Prof, I thank you very much. And my colleagues, Olawole, Ade, and others, allow me to go through the whole list, but you all appreciate it. Well, I acknowledge the Dean, Prof. A.I. Bamboye, for nominating me on behalf of the faculty, all heads of departments, all professors, especially the emeritus professors, surprisingly I've seen some of them here. I thank you for coming. My lecturers, all admin staff, all technology secretaries of the Inaugural Committee, Publishing House, Gather Clinic, Cooperative Society, and Diamond Radio, and the media. Yes, I want to mention Cooperative Society because when things were so bad in this university, ASU Cooperative helped people like us a lot. Yeah, we have our police from Northwestern University in Chicago. Those are our hosts, Prof. Mark, Prof. Murphy, Prof. David, Sarah in particular. The day I was going to the US was the particular day, if you remember, 2014 or so. There was incidents at the Chicago end. Somebody climbed the tower wanted to commit suicide, so they shot everything. I was stranded at Atlanta. I don't know how in Chicago they got information before us, and this Sarah, the secretary, booked accommodation every following for me, and now informed me that I'm not coming to Chicago that night, and that I should see. I was wondering, they started telling me what happened. So I appreciate them very much. Then my collaborators, I thank Professor A.U. for nominating me to the biomedical engineering, Professor Wale, our current HOD, Derek, and others. Yes, those are the team, that's the team that developed the auxiliary temperature monitoring unit, which is, we've gotten the patent in 2024, yet it's not been commercialized. Our other collaborators from UCH, Futua, Jimobi, thank you, Lao, Tech, Bells, Futa, Futu, Unizik, Unilag, because of South Africa and also Johannesburg, my colleagues are legal, CP, and so on. I thank you all. Then my research friends and research collaborators, I thank you all. My students that have supervised across different universities in Nigeria, whether at BSc, MSc, BM, and all of them, I thank you all. Next is my former colleagues at Milan, Nigeria. In particular, I want to appreciate Engineer Roy Oshimbo. He was my manager there. Adedu Sumu was in account, but he was very, very helpful and useful. Up to today, he's my friend. Civil Collier, Benson, John, Funsha Beleye, and a host of others. I thank and appreciate you all. My professional colleagues, the sub family, NSC, NIE, NINWE, Professor Collier, Swike, and all the rest of them. Then on the standard organizations committee, subcommittee, where we're working on the course and standard for Nigeria. I thank all those who have been part of us in that team. There are so many things to say on that. The time is not our friend. Other professional colleagues, that's one of our conferences, and of course, that's when I was being sworn in as the national chairman of the Nigerian Institution of Industrial Engineers. The one beside this is a safety engineer. Next, my Archbishop, who changed my title and added sir to me. The Archbishop, I'm very grateful. And that was all done. Not long ago, he gave me Diocesan Merit Award. So I can now write all those words and join them to my name. Thank you, sir. The chaplain acceptance at the University, I mean, Chapel of Revolution, UI, Library, and all the rest of them. And then those who have helped me along the line at St. Paul's Church, Yemetu, some of them are happily stayed there. You're welcome. I thank you. The prison ministry, I'm a member of the prison ministry at the Chapel of Resurrection here. And what we see in the prison, you won't believe it. That is for another day. The Bible class, Professor Renu and the other professors who teach us there, I learned a lot from you. The Aberdeen wing of Chapel of Resurrection. It was when I got there, I got to know that everybody is going to church. I'm very sorry. Has a special seat where he likes to stay every Sunday. So to my surprise, I see that every Sunday, everybody will just try to maintain his particular seat. Whether there are spaces elsewhere, he wouldn't bother. That is the seat. And I got hooked to that. I thank Marshal Harold Anyaeche and the wife, Professor Henrietta, and other professors. Thank you all, and other members. Through gospel, thank you. I appreciate all of you, both the one you are and the eminent persons. Of course, those are my siblings, my children, Robin Agoli Kelechuku and Chichuku, then my wife, Amaka Anyaeche, who taught me that if the student has not learned, the teacher has not taught. Dedication. I dedicate this to the glory of God and especially to the voiceless amongst us who bear the burden of our collective inefficiencies in our work system. Thank you for your time.